Hey guys, welcome to the lesson on rational exponents. Rational exponents just means exponents that look like fractions. Don't go crazy about the fact that it's fractions. It's actually not too bad in this case, but I'm going to show you what exponent that looks like a fraction actually means. So part one of the rational exponent rule, if your exponent is 1 over n, what's actually going to happen is you're going to get, it looks like this. So n actually turns into a root. So when you see it like this, the bottom number of that fraction is the root. So for example, let's say we had 81 to the 1/2. Our exponent was 1/2. What you're actually going to do is take the square root of 81, which is 9. Part two, what if the fraction isn't a 1 over? What if it's like 3/4? Again, the bottom number is a root and the top number is an exponent. So what happens is you're going to take the n root of a to the exponent m. Or it looks like this. You can write it both ways. Take the root and then do the exponent. So let's do an example of this one. Let's say instead we have 81 to the 3/4. So what you're going to do is take the 4th root of 81 and then do and then cube it. So if we do the 4th root of 81, 4 roots. This is actually 3 to the 3, and 3 to the 3 is 27. So you kind of, the top number of the rational exponent is the exponent part, and the bottom is the root part. Let's do a couple different examples. So evaluating powers with rational exponents. We're going to try to do it without a calculator. So A is 49 to the 1/2. So 1/2 I said was just root. So this is the same thing. And then the root of 49 is 7. That one's super easy. B, negative 64 to the 1/3. So that is the cubed root of 64. Now I'm going to put the negative out here because it's a cube. Then we can have the negative. If it's an odd number on the bottom, it's okay that it's negative. Your answer is going to be negative. If it's an even number, it's not going to be possible. So be careful with that. So 64, the cube root of 64 is 4, so our answer is negative 4. C, 32 to the 4/5. So in this case, I'm going to do the 5th root of 32 first, and then I'm going to do the exponent 4. So 32, the 5th root of 32 is 2. 2 times 2 times 2 times 2 times 2, 5 times is 2 to the 4, and 2 to the 4 is 16. Last one is a little bit more complicated. To the 3/2. So you're going to do the square root of 0.04, and then you're going to cube it. So the square root of 0.04, now I said try without a calculator, I'm going to use one. 0.02 and we cube that. Sorry guys, I had to look at this. I did this wrong. So I'll fix it. 0.2. And then I'm going to cube that. And I get 0.008. So that is how that one, those work. Let's move on to the second page. So rational exponents are useful for solving equations that involves powers. So let's say we had x cubed equals 125. What you're going to do is move that cubed over to the other side. When you do that, it's going to become 1/3, so it becomes a fraction. And then we can easily solve this by taking the cubed root, which will give us 5. Okay, so we can use this examples of rational exponents to solve the equations. Let's look at a couple more examples. So we're going to solve for x, and we're going to assume that x is positive. So A says x to the 4 is 16. So in order to get rid of, move that 4 over, I'm going to make it 1/4. So I make it a fraction on the other side. So we'll take the 4th root of 16, and that is actually 2. B, now this one's a little bit different because we actually have a fraction there. So what happens when you move it to the other side is the fraction flips over. Flips the fraction. So when we do this, it's going to become 27 to the 2/3. So I'm going to take the cubed root of 27, and then I'm going to square it. So cube root of 27 is 3 squared, which is 9. Okay, so just make sure if the fraction is like that, you flip that fraction over. Last example, I'm going to show you like a financial problem, or more of a real world example where you can use rational exponents. Under annual compounding, a principal of 700 grows to 900 in 5 years. Determine the annual interest rate. So A is our final amount. So it is 900 equals our principal, which is 700. 1 plus I, and it happens in 5 years. So when we go about solving this, we're going to move everything that we can and then worry about solving for I. So we'll move everything we can first. So I'm first going to move the 700 by dividing. So 900 divided by 700, 1.28 5714286 equals, this is gone now, 1 plus I to the 5. Now we can easily get rid of that 5 because now we know when we move it to the other side it becomes a fraction. So it's 1.28 5714286 to the 1/5. 1 plus I. So we'll take the 5th root of that. So I'm going to do that. 285. And I get 1.051547497 equals 1 plus I. And to get I to the other side, I'm just going to subtract 1. So it's 0.051 0.05154,749. If you want to, you can round that and say it's 5. You can multiply by 100 and you'll get 5.15% annual interest rate. And there you go. That's how you use rational exponents to make some of the solving with exponents a little bit more easier. Do the practice. Don't forget about the quiz, and I'll see you in the next lesson.